Okay, let's do this. So the page, well, let's ask this. So every one of those problems was worked out, yes?
Yes.
Now, if you chose not to watch the entire video, then you did not see all the problems completely worked out. Problems 7 and 8, those are tough problems. You will not be tested on, can you put the light switch down on your way back, please? You will not be tested on something like 7 and 8, okay? So that's a tougher one, so let's not worry about it. I'm almost done writing the test. There will be a computer part, and there will be, I'm trying to just get a front and back. Let's see, the computer part, questions you might come across might be, solve this system of equations, and then there might be 6 choices to choose from. So it could be 1, 2, infinite solutions, no solutions, things like that. Yeah. Well, we share amongst the department, but I had some time, so I was working on the test that all the other classes would use as well. So our goal for the algebra is we would like to, being that we have a test next week, the test will be on Tuesday, but I'm going to give you the take-home test on Friday at the end of class, so you have the weekend to work on it, and then you'll have all of Monday to also work on it. So that'll give you the opportunity to do that. Would you please pass forward, make sure your name's on first, page 154, 155. Yeah, I'm going to go over the other one. I'm going to go over the other one first. So 154, page 154, 155 is all I need right now, please. Oh, look at that. It was a one-to-one transfer. Yeah, Brandon. Hunter, nice paper.
Sorry, the rip was terrible.
Any more that I need to be picking up? All right. Yeah. Another one. Okay, so yesterday I was able to speak to each of you that were here, obviously, and just kind of talk to you about the ins and outs. So the math science resource room is not open today if you need to take that test. Did any of you take it yesterday that I should know about? So I can go down. You were able to take, was it tough to do? Was it too busy? Was it an okay experience? Okay. So you just walk to the very back of the math science and said, I'm here to take a test for me. And she went in the filing cabinet and said, here you go, and sat down on one of the desks, and then you gave it to her at the end, right? Perfect. Thank you for doing that. So it is possible. So it'll be open tomorrow as well. And then I think on Friday it's also period 1, 2, 3, and 4. It's also open. So I don't know if that's one. And then next week it'll change, but I'll get you next week's schedule if you need that. Some of you, as I told you, are missing assignments for whatever reason. If it's late, you get partial credit. Partial credit is a lot better than nothing. And some of you have grades that are teetering. So you don't allow one of my grades to teeter on you because you chose not to do it. Okay? Get it done. Show what you know. Don't give a false knowledge of what you know by not turning something in. Some of you have C's that I think are B students. Some of you have B's that are A students. Some of you have D's that are C students. Some of you have F's that shouldn't have an F. So take that opportunity to figure that all out, okay? And again, guys and girls, high school is the opportunity to show what you know often in different ways. You show what you know by writing papers in other classes. You show what you know by doing tests and homeworks in other classes. You show what you know by doing presentations. It's, and someone had asked a long time ago, unfortunately, how our public education system works, it doesn't help somebody for the future. And I call bull on that, okay? The thought process that you learn from school is a thought process that allows you to think at a higher level in other situations later in life. Most of you will never come across problems that have intersecting lines saying, oh, look, it's one solution and here's where it's at. But the thought process that develops in your brain by you doing that type of puzzle is a developmental process. The thought process by you doing English papers or Spanish papers or whatever you're doing is a way to develop your thought process to further your learning. Most people with college degrees don't use their specified area college degree in the work setting. Okay? So it's like, well, why would you get that college degree? Because you have now shown that business you have stepped to the next level of thought process, and you should be able to handle that. When people say, oh man, that person has a PhD, they know so much. The thing that you have to understand about a PhD is you know a whole bunch about a single specific topic. Okay? If you get an MD, that means you're a doctor, a DO, a doctor of osteopathy. You specialize in certain characteristics of medicine, but you all have the basic skills of how the human body works and how the human body should heal and how it should be corrected if needed. So, hey. Oh, you need this kid?
Yeah. No, that's him.
That's you?
No, that's not me. That's from this class.
Oh, okay.
Yeah.
Perfect. Thank you.
Yeah.
You are not in trouble with this. That's good. So a lot of people like to get onto the showboat thing going, I don't even use that in life and look at me, ta-da. And it's like, no, ta-da is not the answer. The thought process is you need to go through the rigor of certain things. Now, if you want to be the person saying, hey, I have a friend that, great. I have a friend that, and I guarantee I have a friend that. I have a friend that isn't the norm for society. Okay, so please be cautious. One of my best friends in life, his name's Bill Ebright, he dropped out when he was a sophomore in high school. There was a long period of time that he was part of this business that was very successful. Unfortunately, with 2008 and the big recession that took place, he lost a lot. He is not that successful anymore. He's still happy and doing what he does with life, but he dropped out as a sophomore in high school. If you ask him, hey, do you regret dropping out? He'll tell you every time, yeah, of course I do. Because it closes a lot of doors. Okay? Now, there are times that you have a degree where you might apply for a job, and the job might look at you saying, you're overqualified for this job. And that's, a different scenario as well. So that's my soapbox for you guys. But I just, I want you guys to know, and girls to know, and friends to know that you have the opportunity to show what you know, and don't let somebody tell you that you don't need something. Okay? It's kind of like, oh, you don't need pizza. No, you don't need it, but I don't want to cut it out of my diet because I sure enjoy it. So, I am looking at page 156. That would have been your homework assignment from last night. Okay? So let's talk about, what is the it says, what do you call the tending of rabbits?
Hair care.
Hair care?
Yeah.
Okay. Oh, it's such a funny. So, taking a look at problems 1, 2, 3, or 4. Is there any questions about 1, 2, 3, or 4 on that page 156? Any questions about 1, 2, 3, 4 on page 156? Yeah. 3? Okay. All right, problem number 3. It says you have this. It says tell whether the ordered pair is a solution to the system of linear inequalities. So this is a pretty good skill because the work has already been done for you, and they're saying, hey, this might be one of the solutions to the problem. So what do you think I should do with 9 comma negative 10 to both of my equations? Plug them in. And you want to make sure that they both work. They both give you the correct scenario. So remember, this is an x value and a y value. So I'm going to take this first equation. So the y value is negative 10. It's less than or equal to. The x value is 9, but there's a negative sign in front of the x, so I have to make it a negative 9 plus 9. So is negative 10 less than or equal to 0? Is that a true statement or not?
True.
Totally true, right? Okay, think about it. It's better to owe somebody nothing than to owe somebody $10. Okay? And then we're going to do the same thing with the other problem. So I'm going to take my y value is negative 10. It's greater than or equal to negative 2. My x value is 9. So negative 2 and 9 are going to get multiplied together. Then we're going to add that to 12. So let's see. Negative 10 is negative 10 greater than or equal to negative 18 plus 12. Is negative 10 a larger value than negative 6? Is that true or false? It's false. Think about it on a number line. If you had a number line, you have negative 10 here, you have negative 6 here, you have 0 here. Okay, the further you go to the right, the larger the number. So this creates a false situation. So is this a solution to the problem? No. It is not a solution. So the answer has to be no. I guess it looks like letter E. Would that be? Yeah. 1? Okay. Same exact idea. And I can see where you might get confused on number 1 because you have a point that's given. There's your x and y value. And then you have these two equations. Now, is one of the equation missing one of the letters? Is one of the equation missing one of the letters?
No.
Yeah, I don't have an x on the top equation, correct? So even though I have an x comma y, I don't have to use the whole thing. I just need to look at the y part. So I need to know, is 6 greater than 5? Well, that's true. And now I have an x and y I'll use on the second one. So I have 6 is less than or equal to negative 7. Why is it negative 7? Because I have a negative x already, and then I'm plugging a negative value in. Well, negative is positive, right? So 6 is less than or equal to 11, and that is also true. So they are both true on that one. Yes. All right. 5, 6, 7, 8. Anything there you want to go over? Yeah, go ahead.
Over 2.
2? Number 2 as well? So number 2 is done the exact same way. So you have a negative 8 you plug in for your y value. So it's negative 8 less than 9. That's true. And then if you plug negative 8 and 8 into your x and y, you get negative 8. Is negative 8 greater than negative 16 plus 8? So is negative 8 greater than negative 8? It's equal to it. Negative 8 is equal to negative 8. But if they had the equal sign, so that has to be a no. Anything for 5, 6, 7, 8? Go.
Can you just do like 5 or like any of them? Because I'm confused on how you like figure 5, 6, 7, 8.
All right, I'll just do them all. That work? That encompass one of your questions too. All right. So problem number 5, we have y is less than 5 and y is greater than or equal to x minus 1. So let's draw our XY axis. So this is a horizontal line. Okay? So it's going to be dotted, right? So I'm going to go up 1, 2, 3, 4, 5. Is that okay so far? And then for the second one, I can find my y-intercept at -1. And from there, I'm going to go up 1, right 1. And that's a solid line, right? So it kind of looks like that. It appears that 0, 0 is in a good spot. 0, 0 is below the red line, and it's to the upper left of the green line. Agree? So that's going to be our test. So remember, we're looking for true, true. Okay? So I'm only going to use the y component on this one. So if I look here, I'm going to get is 0 less than 5. Is that true or false? True. Cool. So that means that my answer is going to be shaded completely below the red line. And then I'm going to plug 0, 0 into this one. So I'm going to get is 0 greater than or equal to 0 minus 1 is 0 greater than or equal to -1. 0 greater than -1? So that's a true as well. So that means that this region here is my shaded region. Which appears to be A, right? Graph A, is that right? Cool. Problem number 6.
No, 5 is A. Yep.
Yeah, this should have been an answer A.
So when I did that, like this, see, opportunity is 5, and right here, I just see how much 5,
Oh, I guess. So you use some good deductive reasoning.
Yeah.
That's awesome. That's totally appropriate.
Nothing wrong with that.
Yeah, no, but that's totally appropriate. So your mind works that way. That's beautiful. Okay, that's nothing wrongly wired that way. Wired right. All right, number 6. Number 6, we have y is greater than -3 and x is less than or equal to 2. These are not slanted lines. Okay, so the top equation, this is a horizontal line, 1, 2, 3, and it's dotted. Thanks. Okay? Agree with that so far?
Yep.
All right, and then this is a vertical line. And it was solid. So now if we take a look at 0, 0, do I use both the x and the y value on each of the equations? Do I use the x and the y on both of the equations? So on the top one, what letter am I going to use? So that's an x and a y, so I'm going to use my y value. So I get is 0 greater than -3? Yep, that's true. That means I shade all above the red. Then I plug the 0, my x value is 0 here, so it's 0 less than or equal to 2. Is that true or false? That's true. So we shade the region the 0, 0's in. I don't know what letter that would be. R? And then number 7. All right, what's the y-intercept there? -2, and then go up 1, right 1, solid or dotted? Solid. And then my y-intercept here is 2. And I go up 1, right 1. So these are parallel lines. They're both solid parallel lines. It's pretty obvious that C is going to work because that's the only one with parallel lines. If you pick 0, 0 to see if it works, to see where you shade, they should show in the middle. So if I plug it in, I get 0 is greater than or equal to 0 minus 2. Is 0 greater than or equal to -2? That's true. And then on this one, is 0 less than or equal to 0 plus 2? Is 0 less than 2? It's also true. So that's why you shade in between the two, which would be letter C. And then problem number 8. Problem number 8. These are both set up to use the cover method. Agree?
Yep.
Cool. All right, so if I cover up y, x is equal to 4. If I cover up the x, y is equal to 4. Solid line. 0, 0 is right down here underneath it. Let's do this one. Cover method, x equals 5. 1, 2, 3, 4, 5. Negative y equals 5. So negative 5. It's also a solid line. Let's check to see if 0, 0 is our good test point. Shh. A little too much chatty going on. All right, so if I take 0, 0, plug it in here, I get 0 plus 0, which is 0. Is 0 less than 4? That's true. That means I shade the region here. I shade this region all underneath there. Oh, look at that. The ruler even works. Right? So, but then let's try it on this one. Let's plug 0 minus 0 is less than or equal to 5. Is 0 less than 5? That's also true. That means we have to shade everywhere above the red. Where both regions work is here. And I don't know what letter that is. H. That's how you do it. Name on that. Pass it forward, please. Name on that. Pass it forward, please. Thank you. Thanking you. Thanking you. You got one? 2? You didn't pass it forward. Jasper ignoring you? Yeah. It's okay if he is. He has all the right ones. Thank you, guys. All right. Play for the big red dog. All right. Let's get ready to rumble. Ladies and gentlemen, let's get ready to rumble. There you go. There you go. Oh, it's coming in. It can't be seen. Got it. Someone's got a phone keeps dinging along, so. Is he all right? Hey, Sean, you know my trick to get rid of that headache, right? What was it again? Right there. And then right here. Both inside, outside. You get there. I promise. All right. Hey, let's do this. So this is, we're going to be doing systems equations with word problems. So it's the same thing we're doing, but we create a word. Did I even have one? All right, sorry. Okay. So we're going to write systems using a word problem. So we get story problems. Yay! All right. So when you label your variables, you can really label them anything you want. But what gets hard is if you start graphing something and you start labeling something like C and P, you're like, where do I plot C? Where do I plot P? So it's best to label things using the X and Y because you know where those will find. And then set up the equation, solve the system, and check the solution. Now, a lot of times we're not going to graph these. We're going to just use probably elimination or substitution. So let's take a look at this one. One number is 5 more than twice another number. The sum of the two numbers is 26. find the two numbers. So I made these a little larger so you had a little bit bigger area to write in. Okay, so one number is twice, it's 5 more than twice another number. So one number, so let's highlight a few things that we might know. Okay, one number, and then is 5 more than twice another number. Okay, so you have the pink and you have the yellow that are representing some sort of number. Hey, what does the word is mean in math? Equals, right? So, that. So one number is 5 more than twice another number. Find the sum. The sum of the two numbers is 26. So if I take my two numbers, x and y, I know that if I add the two numbers together, I'm going to wind up with 26. So I created my equation, one of my equations, looking at the second sentence. Okay? If you know that x plus y equals 26, do you have enough to solve what x or y would be equal to? As of right now, I would think they're all whole numbers. So you have either 0, 26, 1 and 25, 2 and 24, 3 and 23, all the way through. But we're just assuming they're whole numbers. So let's call x the one number, and we'll call y the other number. Yes, I'm using hashtag, but the pound sign, that's the pound sign back in the olden days, means number, right? I'm not doing y'all can't giggle at me saying, dude, you got the hashtag on the wrong side. It shouldn't be hashtag 1. I know. Sorry, my limited knowledge of things. So one number is 5 more than twice the other number. So one number is 5 more than twice the other number.
Mr.
Yeah.
How do you know that x will be there and y will be there?
I had to just assign x. I could have had it as y equals 5 plus 2x, but I just kind of was like, okay, I have to start someplace. It didn't really decipher, one number was bigger than the other, but by just assumption, we might be able to decipher that. But I just knew that if I said one number, so I'll call that one number x, that's where the equal sign is going to kick in there, is 5 more, so 5 more, I'm adding 5 to something, then twice another number, so you're doubling the second number. So I just figuring out how to set it up someplace. Cool? All right, so take a look at these two equations here and here that I have set up. How are these set up for us to solve? Are they set up for the addition method? Are they set up for graphing? Or are they set up for substitution? Substitution work? All right, if we say, hey, this is going to work for substitution, I can take this right here, and I can plug that in right there. Agree? All right, so I'm going to go 5 plus 2y plus y equals 26. Okay, combine like terms, so I get 5 plus 3y, because 2y and y is 3y. And then I'm going to subtract 5 from both sides. And then I'm going to divide each side by 3. So now I have 7 as one of my numbers. How in the world do I figure out the first number? Yeah, plug it in. I need to figure out what the x number is. So here's one of my answers right here. Now you can use logical thinking, inductive reasoning, talk about it, or you could say, you know what, I can either plug that y value in right here, or I can plug it in right here. It doesn't really matter which one you plug it into because it's going to be the same on both. So I'll plug it in here. So I have x plus 7 equals 26. Subtract 7. So my other number is 19. So my two numbers, I have one number that's 19, the other number that is 27. Or 7, excuse me. There's no 20 in front of that. Make sense? Can I move to the next problem?
Yeah.
Problem number 4. Oh boy. You bought donuts. Dude, I love donuts. Jelly's my favorite. Sorry, I had a little donut moment just now. On Monday, Joe bought 10 cups of coffee and 5 donuts for his office at the cost of $16.50. We understand what's going on here? So Joe came walking in. He had, hold something in his hands. It happens to be 10 cups of coffee and 5 donuts, and he wound up spending $16.50. Turns out the donuts were more popular than the coffee. No kidding, I like donuts, man. If they're donuts versus coffee, I like coffee too, don't get me wrong. Man, if I have a choice between a donut or a coffee, I'm going donuts every time. I don't care what my wife says. On Tuesday, he then came to the office with kind of the flip-flop. He had bought 5 cups of coffee and 10 donuts, and that only cost $14.25. So how much was each cup of coffee? So let's do this. Let's say that X will be the donuts. If I could spell, I'd be a much better person. Donuts. And Y will make the coffee. Is that okay? That says donuts. Just go with it. Yeah. For you, I'm going to make the whole thing. Earbuds in here. Your whole test will be word problems. Everyone else has only 3. Yeah.
Which are we doing 25 or 16?
We're going to actually do both. Okay? So, we have to recognize we have 10 cups of coffee here and 5 donuts. So one of our equations is going to be 10, our coffee is Y, plus 5 donuts, which is X, and that's 1650. Did I make that work? Did I label it right? Okay, you got to double check me because it's word problems and sometimes it gets goofy. Okay? So then for my other equation, so let's underline, so 1650. And then my other equation, we have Tuesday, he did 5 cups of coffee and 10 donuts for this. So then I have 5 cups of coffee. My coffee was what letter? Y. And 10 donuts, X, equals $14.25. Do we have a solution kind of going up here? Okay, so I have 2 problems. I have 10y plus 5x equals 1650. Then I have 5y plus 10x equals 1425. So I think I could probably choose a letter to get rid of. I might choose, I don't know. Hey, Brandon, what do you want? Get rid of X or Y? Y, okay. We're going to get rid of Y first. Okay, so I'm going to multiply this whole equation here by -2. And the reason I'm choosing -2 is that will give me a positive 10y on top and a negative 10y on bottom. When I add the 2 equations together, the y's will cancel out. Does that make sense? Yeah. Okay. If you have a calculator, I need help because I can't do this. I can do -2 times 5y. That's 10y. And that's negative 20x. And then that's negative 2850. Thank you. Negative 2850. Does everyone agree why we have negative signs in there now? Okay, so what 2 equations will I have to add together to start solving? Top and the bottom. Top and the bottom. Good. So I have the top equation here and the bottom equation here that are going to get added together to work. So the nice thing is when we do this, if I add these 2 equations together, 10y minus 10y, the y's are gone. 5x minus 20x is negative 15x. And then 1650 minus 2850 is, don't know.
That's negative.
Negative 12? Okay. So then I'm going to divide each side by 15. And it's negative over negative. And so will you do 12 divided by 15 on a calculator? Just tell me the decimal. 0.8? Well, it's negative divided by negative, so it
It's 0.8.
should be 0.8. So, okay, let's pause for a second. Okay, what does 0.8 mean in the reference? Yeah,
80 cents.
80 cents. So what's costing us 80 cents here? Donut. We said X equals donuts, right? So each donut is going to cost us 80 cents. So now let's figure out how much the coffee costs. So I have an X equals 0.8. So I could plug that into here, or I could plug it in here. I could even plug it in here if I wanted to. I think I like this blue one to plug it into. Why would I say that?
That's easy.
It is easier. I'm multiplying 10 times 0.8, which is going to be 8, right? So let me take this equation here, and we're going to plug in the 0.8. So I get 5y plus 10 times 0.8, that's 8, right? Equals 14.25. Subtract 8 from both sides, so now I get 14.25 minus 8 is 6.25, I believe. And then divide each side by 5, so I get 1.2 buck and a quarter.
Yeah.
Did I do that right?
Yeah, you did.
Cool. So each coffee cost me a buck and a quarter. Each donut cost me 80 cents. Or, in this case, Joe, whoever Joe is. I know that, you know what, I don't like Joe a whole lot. You want to know why? Because I don't see any donuts in here for us. Yeah, Joe, he's a punk. I'll tell you what, you see Joe in the hall, you let him know I'm upset with him. May I move down?
Yep.
We good to go? Yay? All right. Your next test is worth 150 points.
Oh.
It really isn't. This is just a story. Okay. Your next test is worth 7,000 points. I'm just kidding. All right. There are a total of 46 questions. Some are 3-point and some are 5-point questions. How many of each type? So I'm going to have X and Y. X is going to be, I don't know, should X be our 3-point problem or a 5-point problem? I don't know. 3? Okay. So X is our 3-point problem, and then that would make Y our 5-point problem. Everyone feel comfortable with this? So if you, just like anytime you take a test, what's one of the first things you do before you put your name on it? You flip through the test, see how many problems there are, right?
Yeah.
So how many problems are on the test? 46. Okay, so I don't know how much each of these problems are worth, but I realized, dude, there's 46 questions on this test. And that's usually where a little anxiety starts setting in going, oh no. Yeah. Okay, watch what's going to happen. We're going to use that 150 here. I like how you're thinking. So, in order for me to get to that 150 points, I have some problems that are worth a certain amount and some other problems that are worth another certain amount. Okay? So what we're going to do is my X problems are worth 3 points each, right? My Y problem are worth 5 points each, and that's going to give me the 150. Okay? So, the first equation, the purple one, is you just open up the test and you kind of flip through it and said, oh my gosh, there's 46 questions on it. The second question might be, let's say the teacher put next to each question 3 or 5, or told you the whole, hey, there's some problems that are worth 3, some are worth 5, the whole test is worth 150 points, go. So you maybe you don't know right off the bat which ones are worth 3, which are worth 5. Yeah.
So, because some are worth 3 and some are worth 5, couldn't there be a variety of different answers?
Well, there's only going to be one in this situation because these are two lines that actually will cross. So there's only one combination that works. Now, if I said, hey, you have 46 questions, some are worth 3 and some are worth 5, and I didn't tell you what the total point value is, you're absolutely right because I gave you the parameter of that. Yeah.
Saying 3x plus 5x equals 150. That's like, because the x is already worth 3 points, so you don't have to put 3 in front of it because that's saying there's 3 problems.
So, but if I had 10 problems that were 3-point problems, then we would know 30 points would come from the 3-point problems.
Why would you put numbers in front of x?
Because it's a value. We have a value and we have a point value that we know we establish. So of the 46 questions, so you look at your test, there's 46 questions, we agree there. And then let's say I tell you, hey, there's some problems that are worth 3 and there are some that are worth 5 points. The total this test will be worth is 150 points. So you would take however many of your 3-point problems, so let's say there's 6 of them, so 3 times 6, so that means 18 points are now being accounted for. And then you take whatever your Y problems are, and multiply that by 5, and let's say there's 10 of them, that'd be 50 points. So there's somehow a certain combination is going to work that'll be exactly right. So there's the counting one. And this is really related to the nickel and dime and penny problems, and we're going to see one of those next, where you have a monetary value, and then you realize, hey, I have this many coins in my hand. So right now I have this many questions. I know some are worth 3, some are worth 5. Okay? All right, so these are set up as elimination. I think I would like to get rid of x. I'm going to multiply this whole top equation by -3, because now when I add -3 to my bottom equation, negative, let's see, 18, 1, 12, 13, 138. Is my math done right? Let's add those. What cancels out right away if I did it this way? Yeah, the x's are gone. And then 5y and 3y, that's 2y, equals 12. So now I have 6 questions that are the y question. How much are the y questions worth? 5 points, right? So let's solve this and we're going to see if this works. So now I know that I have 6 y problems, so I'm going to use that top equation. So I have x plus y equals 46. I know that my y problems is now 6. Subtract 6 from both sides. So now I have 40, and I think I might be able to answer your question now. So watch this. This was the only combination of numbers that's going to work. That's going to give us having 46 questions. I have 46 questions because I have 40 of this type, 6 of this type. Agree? If I add 40 and 6 together, I get 46. Now, if I go 40 times 3, that gives me 120 points. Agree? If I go 5 times 6, that gives me 30 points. If I add 120 and 30 together, I get my 150 points. What?
I see the border quick.
Yep. Yeah.
Where'd you get -3?
I had to choose to get rid of either x or y. So I wanted to, between the purple and the blue equation, I wanted to have an opposite x value. I could have done the whole top by -5, and that would have eliminated the y's. I just had to choose one of them to get there. All right, guys and girls, word problems. There was one more slide. We'll get to that later. Where am I going? All right. I would like you to try page 162, 163. I want you to try that. Okay? Does try mean you came in with a blank? No. So I tried it and I didn't know where to start. Put your pencil on the paper first. So that's what we got. So give me a good try on page 162, 163. Guys and girls, get out of here. Have a great day. Remember, if you need to make up those quizzes, you know where to go. If you need to make up the test with me, you know where to find me.